For problem 1, I want to graph y is equal to negative x squared minus 9 times x plus 2 squared. The first thing I need is it to be in factored form, and it is mostly factored, but it could be factored even further. I look at this first factor, x squared minus 9, and I know that's the difference of two squares, and it can be broken down even further. So I want complete factored form because I need factored form in order to find my important points that are going to be on my graph for these higher degree polynomials. So I'm going to rewrite this as y is equal to negative. I'm going to change x squared minus 9. I know that's x squared minus 3 squared, which means I can break it down further into x plus 3 times x minus 3. X plus 2 squared, I'm just going to write out as x plus 2 times x plus 2, so I can more clearly see what's going on. The first thing I want to find from this factored form are my x-intercepts, and I know my x-intercepts are when y is equal to 0. So for this product to be equal to 0 of all these factors multiplied together, either this is 0, or this is 0. I know one of those three things has to be equal to 0. So x plus 3 is equal to 0, x minus 3 is equal to 0, or x plus 2 is equal to 0. And I didn't repeat that because I had x plus 2 two times. So for my x-intercepts, I know I have negative 3 from this x-intercept, I have positive 3 from this x-intercept, and I have negative 2 from this x-intercept here. Those are the x values that are going to make these three functions equal to 0. All right, for my y-intercept, I know I can find my y-intercept by plugging in x is equal to 0, always, because I'll be on my y-axis when x is equal to 0. So I'm plugging in, everywhere I see an x, I'm plugging in 0, and I'm going to do it with this form here. So I have that negative in front times 0 minus 9. I'm going to have negative 9 times x plus 2 is going to be 0 plus 2, so 2 squared. And when I do this through, I get negative 9 is positive 9. I have 9 times 4, which gives me positive 36. So my y-intercept is going to be 36. And I'm going to plot that important information. So just sketching here. So my y-intercept, I don't want to do that. My x-intercepts are, I have negative 3, positive 3, and negative 2. And then for my y-intercept, I'm not going to draw 36 dashes. I'm just going to put 36 up here, label it 36, and put a point there. And then I need to talk about what's my end behavior going to look like. So I know that if I were to multiply all of these terms together, I'm looking at my highest powers and multiplying those together to see what my highest power is, because that's going to tell me the degree of the equation, which is going to tell me the end behavior. And I also need to multiply that negative 1 that I have in front. So when I do that, I'm going to end up with y is equal to, that's x multiplied together 4 times, so that's x to the 4th power, and then I have that negative 1 in front. So the end behavior here is going to model y is equal to negative x to the 4th power, which I know as I go to negative infinity for x, I'm going to negative infinity for y. As I plug in higher and higher positive values, I'm going to get out smaller and smaller numbers. So as I go to the right, I'm going downwards as well. To fill in this information here, as x goes to negative infinity, so as it's going this way, y is also going to negative infinity. And as x goes to positive infinity, so as I go to the right, y is going to negative infinity as well. And I'm going to use that information to start connecting these points. So I'm going to do the end behavior first. I have the end behavior on the left, I'm going downwards, and the end behavior on the right, I'm going downwards. If I see a multiple 0, I know that I'm changing direction at that point. Otherwise, I'm going straight through the points. So I look at, do I have a multiple 0 here? And I do. I have x plus 2 shows up 2 times. So the x-intercept negative 2, I should be changing directions at that point. I'm going to be changing directions at that point. Otherwise, I'm going directly through. So this point here, I know I was going upwards to get to that point. I'm going to continue through it going upwards. At some point, to get to the next x-intercept, I need to turn around. So I'm going to turn around roughly in between the two x-intercepts, and I'm going to end up here. At this point, I circled it because it's a multiple 0 with a multiplicity of an even amount, so I need to change direction at that point. Just like I would when we were talking about the vertex of parabolas. If we saw a term 2 times, we knew that that was the vertex of the parabola, and it was going to change direction at that point. So I'm changing direction here. I'm going up to my y-intercept, and eventually I have to go back down to get to my last x-intercept, which I should be going straight through, which I am, if I look at my end behavior there. And that's my graph. This here is a relative maximum, and here is a relative minimum.